So today we discuss algebra of continuity of a function. Algebra of continuous functions. If f and g are real functions, continuous at x is equal to a, then first one, f plus g is continuous at x is equal to a. Second one, f minus g is continuous at x is equal to a. Third one, f into g is continuous at x is equal to a. Fourth one, f by g is continuous at x is equal to a, providing g of a is not equal to 0. So this is solution or proof. Here given f and g are continuous at x is equal to a. Here given f and g are continuous at x is equal to a. So this means what? F and g are defined at x is equal to a. Limit f of x as x tends to a is equal to f of a. G of f of x as x tends to a is equal to g of a. So f and g are continuous at x is equal to a means, hence f and g are defined at x is equal to a, hence f plus g comma f minus g and f into g are defined at x is equal to a by algebra of continuous functions. If f and g are defined at x is equal to a by algebra of continuous functions, f plus g, f minus g and f into g are also defined at x is equal to a. Also f by g providing g of a is not equal to 0, defined at x is equal to a. So f and g are continuous at x is equal to a means f and g are defined at x is equal to a. So by algebra of continuous functions, f plus g, f minus g, f into g are also defined at x is equal to a. F by g providing g of a is not equal to 0, so defined at x is equal to a. Also given, f is continuous at x is equal to a means limit f of x as x tends to a is equal to f of a, and g is continuous at x is equal to a means limit g of x as x tends to a is equal to g of a by definition of continuous functions. So now the first one, f plus g is continuous. What is the condition for limit of a function at x is equal to a? What is the definition? So limit f of x as x tends to a is equal to f of a. The function f of x is said to be continuous at x is equal to a. So here f plus g is defined at x is equal to a. We have to prove limit f plus g of x as x tends to a is equal to f plus g of a. So we need to prove. So now consider, so limit as x tends to a f plus g of x by algebra of functions. limit by algebra of limits, limit f of x as x tends to a plus limit g of x as x tends to a. Now limit f of x as x tends to a is equal to f of a plus limit g of x as x tends to a is equal to g of a. Again by algebra functions, this is f plus g of a. So therefore, f plus g is defined at x is equal to a, and the limit of this function as x tends to a is equal to f plus g of a. So by definition of continuous functions, f plus g is continuous at x is equal to a. So this is the proof. Second one is f minus g is continuous at x is equal to a. So here f minus g is defined at x is equal to a. We need to prove limit as x tends to a, f minus g of x is equal to f minus g of a ಅಂತ prove ಮಾಡಬೇಕು ನಾವು. So limit f of x, so take minus. Second question, limit f minus g of x as x tends to a is equal to, by algebra of limits, limit of f of x minus limit of g of x as x tends to a. Again limit f of x as x tends to a is equal to f of a minus limit g of x as x tends to a is equal to g of a. So by algebra functions, f of a minus g of a is equal to f minus g of a. Therefore f minus g is continuous at x is equal to a. Similarly we can prove, here replace minus by into, minus by into. So replace minus by into, f into g is also continuous at x is equal to a. Replace minus by division, divided by f by g. So limit f of x as x tends to a divided by limit g of x as x tends to a. So finally we get f by g of a. So therefore f divided by g is also continuous at x is equal to a. So by algebra of continuous functions, we conclude that f and g are continuous functions. Sum of two continuous functions is continuous. Difference of two continuous functions is continuous. Product of two continuous functions is continuous. Division of two continuous functions is also continuous, providing denominator is not equal to 0 at that point. Next, here f of x is continuous at x is equal to a. Note, if f of x is continuous at x is equal to a and k is any scalar, then first one, k into f. Here k is a constant, f is a continuous function. Product of two continuous function, we know that every constant function is continuous. F is given continuous at x is equal to a. So therefore product of two continuous functions is also continuous. By algebra of continuous functions, is continuous at x is equal to a. And second one, k divided by f. Here f of a is not equal to 0, so is continuous at x is equal to a. So therefore here k is constant, f is continuous function at x is equal to a. So we know that constant function is continuous. Product of two continuous is continuous. K into f is also continuous at x is equal to a. So k by f is also continuous at x is equal to a. So these are very very important to solve the problems. Next theorem, if f and g are real functions, if f and g are real valued functions, such that g of f, that means composition of two functions f and g, is defined at x is equal to a if f is continuous at x is equal to a and G is continuous at f of a, then G of f is continuous at x is equal to a. So this is the theorem. Here given f and g are real valued functions. G of f is defined at x is equal to a. Also given if f is continuous at x is equal to a, here given f and g are continuous. F is continuous at x is equal to a, that is limit f of x as x tends to a is equal to f of a. Also g is continuous at x is equal at y is equal to f of a, so that is limit g of y as y tends to f of a is equal to g of f of a. By definition of continuous function, f is continuous at x is equal to a means limit f of x as x tends to a is equal to f of a. So g is continuous at y is equal to f of a means limit g of y as y tends to f of a is equal to g of this value, that is g of f of a. So these two values are given. Also given since g of f is defined at x is equal to a, here to prove g of f is continuous at x is equal to a means we have to prove limit g of f of x as x tends to a is equal to g of f of a. If this condition satisfied, the function, the composite function g of f is continuous at x is equal to a. So we need to prove limit g of f of x as x tends to a is equal to g of f of a. Now consider limit g of f of x as x tends to a is equal to, so by definition of composition of two functions, limit g of f of x is equal to g into f of x as x tends to a. So this is equal to limit as x tends to a f of x tends to f of a. So therefore as x tends to a is same as f of x tends to f of a, so limit f of x tends to f of a, g of f of x, since as x tends to a, f of x tends to f of a. Now f of x is equal to y, so limit y tends to, because y is equal to f of x, y tends to f of a, g of f of x is equal to y, since y is equal to f of x. So this is limit g of y as y tends to, limit g of y as y tends to f of a is equal to g into f of a. So this is g into f of a. By definition of composite functions, this is g circle f of a. So clearly limit g of f of x as x tends to a is equal to g of f of a. So therefore composite function g of f is continuous at x is equal to a. So therefore we conclude that f and g are real valued functions. Here f is continuous, g is continuous, composition of two continuous functions is also continuous. So these are the very very important. So next exercise 5.1. The first one, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. So this is the question. Now you're given f of x is equal to 5x minus 3, 5x minus 3. So to show this function is continuous at x is equal to 0, when we say the function f of x is continuous at x is equal to a, so limit f of x as x tends to a is equal to f of a, the function f of x is said to be continuous at x is equal to a. So therefore your limit f of x as x tends to a is equal to f of a. So here first find the f of a value. So at x is equal to first value at x is equal to 0, at x is equal to 0, what is f of 0 value? F of 0 at x is equal to 0, f of x is equal to 5x minus 3, f of 0 value is 5 into 0 minus 3. So 5 into 0 is 0, 0 minus 3 is equal to minus 3. F of 0 is minus 3, it is a real number. The function is defined at x is equal to 0. Now limit f of x as x tends to 0 is equal to, so f of x is limit f of x is equal to 5x minus 3 as x tends to 0. Here put x is equal to 0, that is 5 into 0 minus 3, that is also minus 3. So clearly, so your minus 3 is same as f of 0. So therefore limit f of x as x tends to 0 value is f of 0. So therefore by definition of continuous function, f of x is continuous at x is equal to 0. Similarly at x is equal to 1, at x is equal to minus 3, at x is equal to minus 3, so find the value of f of minus 3. F of minus 3 is equal to, so put x is equal to minus 3, so 5 into minus 3 minus 3, that is 5 into minus 3 is equal to minus 15, minus 15 minus 3 is equal to minus 18. So what is the limit of function? Limit as x tends to minus 3, f of x, here f of x is given 5x minus 3 as x tends to minus 3. Direct substitute x is equal to minus 3, so 5 into minus 3 minus 3, that is also minus 18. So this is exactly same as f of minus 3. So therefore limit as x tends to f of x tends to minus 3, f of x is equal to f of minus 3. Therefore the function f of x is continuous at x is equal to minus 3. Similarly we can prove at x is equal to 5 also. At x is equal to 5, so f of 5 value, limit of that limit of function as x tends to 5, if both are equal, we say that f of x is continuous at x is equal to 5. So you do third problem at x is equal to 5. Next, question number 2. Examine the continuity of the function. Question number 2. Examine the continuity of the function f of x is equal to 2x square minus 1 at x is equal to 3. At x is equal to 3. Here given f of x is equal to 2x square minus 1. So at x is equal to 3. At x is equal to 3. So first to find the value of f of 3. The function is defined at x is equal to 3 or not. At x is equal to 3. F of 3 value is 2 into 3 square minus 1. 3 square value is 9. 9 2s are 18. 18 minus 1 is equal to 17. So the function is defined at x is equal to 3 because f of 3 value is real number. Next, limit of a function. Limit f of x as x tends to 3 is equal to limit, here f of x is 2x square minus 1 as x tends to 3. Direct substitute x is equal to 3. 2 into 3 square minus 1, that is 18 minus 1, the value is 17. 17 is exactly same as f of 3. So therefore limit f of x as x tends to 3 is equal to f of 3. Therefore by definition of continuous function, f of x is equal to 2x square minus 1 is continuous at x is equal to 3. So this is the second one. Third one, examine the following functions for continuity. Question number 3, examine the following functions for continuity. In which first problem is f of x is equal to x minus 5. So examine the continuity of the function. Here f of x is equal to x minus 5. F of x is equal to x minus 5 is a polynomial function. Is a polynomial function. We know that every polynomial function is continuous. Function is continuous for all x belongs to R. So therefore f of x is equal to x minus 5 is continuous function. So properties: every polynomial function is continuous, every constant function is continuous, identity function is continuous, modulus function is continuous. Next, last two, algebra of continuous functions. Sum of two continuous functions is continuous, difference of two continuous functions is continuous, product of two continuous functions is continuous, division of two continuous functions is also continuous, and last one is composition of two continuous functions is continuous. So we know that every polynomial function is continuous for all x belongs to R. So therefore this function f of x equal to x minus 5 is a polynomial function. Therefore every polynomial function is continuous. F of x equal to x minus 5 is a continuous function. Next, question number 2. F of x is equal to 1 by x minus 5. Here x is not equal to 5. So therefore here f of x is equal to x minus 5. So domain of f of x is equal to 1 by x minus 5 is all real numbers except 5. Except 5, the function 1 by x minus 5 is defined. Therefore the domain of f of x equal to 1 by x minus 5 is set of all real numbers other than 5. Next, here 1 is a constant function, x minus 5 is a polynomial function. Denominator is not equal to 0 when x is not equal to 5. So therefore this function in this domain 1 by x minus 5 is defined, and numerator is constant, denominator is polynomial. We know that the division of two continuous functions is continuous. Adunu prove madabodu illa andre. So let a belongs to r minus, let a belongs to r minus 5 be any real number. Any real number, arbitrary, take any. So take a is any real number in the domain of given function f of x. F of a value is f of a is equal to 1 by a minus 5. Here a minus 5 is not equal to 0 because here a value is not 5. A is equal to other than 5. Next, limit f of a, limit f of x as extends to a is equal to 1 is equal to limit f of x is 1 by x minus 5 as extends to a. By direct substitution method 1 by a minus 5. So this is exactly same as f of a. So therefore f of x is continuous function in the domain of given f of x. Here the domain is continuous function at x is equal to a. Here a is what? Any point in this domain. So therefore f of x is continuous function. For all x belongs to r minus 5. So in the given domain, the given function f of x is continuous. Next, Third one is C. F of x is equal to x square minus 25 by x plus 5. Here x is not equal to minus 5. Here what is the domain? So domain of f of x is r minus of minus 5. At x is equal to minus 5, denominator is not equal to 0, the function is not defined except minus 5. F of x is defined for all real numbers. So therefore the domain of f of given function is all real numbers except minus 5. So the letter a belongs to r minus 5 in the given domain. A is be any point in the domain, be any real number in the given domain, arbitrary point. Here f of a is equal to, so put x is equal to a square minus 25 divided by a plus 5. Here a square minus 25 is equal to a plus 5 into a minus 5 divided by a plus 5. So these two get cancelled, that is a minus 5, f of a value. Next, limit f of x as x tends to a is equal to limit f of x. F of x is x square minus 25 divided by x plus 5 as x tends to a. Here directly a is real number other than minus 5. So if a is equal to minus 5, the function is not defined. If the domain is a belongs to domain, so all real numbers except minus 5. If a is not equal to minus 5, denominator is not equal to 0, the function is defined. So therefore limit as x tends to a, x plus 5 into x minus 5 divided by x plus 5. So get cancelled. So now apply the limit. So a minus 5. So clearly f of a value is same as limit of this function. This is f of a. Therefore f of x is continuous at x is equal to a. Here a is any point in the domain. So therefore f of x is continuous function. Continuous function for all x belongs to in the given domain r minus 5. So this is the proof. Next, question number 4. Question number 4. Prove that the function f of x is equal to x power n is continuous at x is equal to a, where n is a positive integer. Solution. Here given f of x is equal to x power n. Here what is the domain of this at x is equal to a? We need to check the continuity at x is equal to a only. At x is equal to a, when we see the function is continuous at x is equal to a, limit f of x as x tends to a is equal to f of a. First find f of a value. So f of x is equal to x power n, f of a value is a power n, and limit f of x as x tends to a is equal to, so limit f of x is given x power n as x tends to a by direct substitution method. So this value is a power n is the same as f of a. So therefore your limit f of x is continuous at x is equal to a. So this is the fourth problem. Just at x is equal to a, find the function value. So function value is a power n. Next find the limit of this function at x is equal to a. So we get a power n. So this is same as f of a. Therefore the function by definition of continuous function, f of x is continuous at x is equal to a. Next question number 5. Is the function f defined by f of x is equal to x if x is less than or equal to 1, phi if x is greater than 1, continuous at x is equal to at x is equal to 1, sorry, at x is equal to 0, at x is equal to 1, at x is equal to 2. 3 questions. Your given function is you're given f of x, given function is x if x is less than or equal to 1, phi if x is greater than 1. Right. So first question, at x is equal to 0, at x is equal to 0, what is the function value first? So prove that the given function f of x continuous at x is equal to 0. Is continuous or not? We have to check. So at x is equal to 0, what is f of 0 value? When we say the function is not continuous or continuous, limit f of x as x tends to a is equal to f of a, the function is said to be continuous at x is equal to a. Suppose function value does not exist, the function is not continuous at x is equal to a, or limit of this function does not exist, we say the function is not continuous, or limit exists, function value exists but not equal, again we say the function f of x is not continuous. So limit exists and function values exist and both are equal, we say that f of x is continuous at x is equal to a. At first find the f of a value, that means f of 0 value is, here at x is equal to 0, here 0 value is less than 1 or greater than 1. So 0 is less than 1, if 0 is less than, x value is less than 1, function is f of x is equal to x, that is f of 0 is equal to, f of 0 is equal to 0. So that is f of 0 is 0. Next, when the given function is classification form, so to find the left hand limit, whenever the given function f of x is classification form, so limit f of x as x tends to a exist means left hand limit is equal to right hand limit. When the given function f of x is in classification form, so first find LHL and RHL. LHL is equal to RHL, f of limit f of x as x tends to a is exist. LHL is equal to RHL is equal to f of a. The function f of x is said to be continuous at x is equal to a. So now f of 0 is equal to 0, given the function is classification form. So now we have to find limit, left hand limit. So left hand limit is limit as x tends to 0 minus f of x. Here x is, so this is 0, so this is 1. X tends to 0, x tends to 0 minus means x is close to 0 from left side, this point is less than 1. So x is close to 0 from left side, that means what, x value is, this value is less than 1. So x is less than 1, the function value is f of x is equal to x, that is limit f of function value is x as x tends to 0. Direct substitution method, the value is 0. Next, right hand limit is limit as x tends to 0 plus f of x, that means x is close to 0 from right side, this is the point, this is also greater than, so this is also less than 1, so this is also less than 1. When the x value is less than 1, function value is x, so that is limit x as x tends to 0, again direct substitution method, the value is 0. So clearly LHL is equal to RHL is equal to LHL value, RHL value same, and f of 0 value is also same. So therefore f of x is, given function is continuous at x is equal to 0. So this is the first one, at x is equal to 0, the given function f of x is continuous. Next we have to check at x is equal to 1, right? At x is equal to 1, f of 1 value, f of 1, x is equal to 1, function value is f of x is equal to x. So f of 1 is equal to 1. So function value is also 1. Left hand limit is x tends to 1 minus f of x is equal to limit f of x as x tends to 1 minus, that is left hand limit. When x tends to 1 minus means x is less than 1, x is less than 1, the function f of x is equal to x. So direct substitution method, the value is 1. Right hand limit is 1 plus, that means x is close to 1 from right side, that is x greater than 1, x is greater than 1, what is the function f of x is greater than 1, f of x is equal to 5, so 1. So limit of constant function is constant itself, so clearly LHL is not equal to, LHL value is 1, RHL value is 5, so clearly LHL is not equal to RHL, therefore f of x is not continuous or discontinuous, not continuous at x is equal to 1. Next, at x is equal to 2, so you solve that problem. At x is equal to 2, find the f of 2 value, left hand limit, right hand limit. If all are equal, So f of x is continuous at x is equal to 2. Otherwise, the function is not continuous at x is equal to 2.